Here we go. So we're going to go through exercise 14I, question 1I. Okay, so we're going to do this one together. It wants you to sketch. Oh, it says only one cycle. Maybe that's too. I'm going to change this question. I'm going to say, let's make it between, let's do 0 to 2 pi to start off with, just to make it easy for you. Okay? All right. Here we go. Let's copy this. Here we go. So I want you to be able to sketch question I. Here we go, let's have a look at I. I has y equals to -3 cos. I'm going to do a cos version because we've been doing sine. 2 of theta, which is your x, plus pi over 2. Where theta is an element of 0 to 2 pi. There we go. Copy that question down as an example. Your goal is to be able to sketch this. Okay, so that's what you want to be able to sketch. There's a lot of elements here. Let's break it down apart, or break it apart. What's the negative do to the graph again? What's a negative do?
It inverts it.
Inverts, it's a reflection. Now there's a reflection on the x-axis or a reflection on the y. Which one is this one?
X.
Reflection on the x-axis. Very good. This is reflection on x-axis. For those who don't know what that means, it just means it flips over the x-axis. Okay, so it flips vertically, if you like to think of it that way. Okay, so we've got the reflection on the x-axis. We know it's a cos graph. Now, normally a cos graph looks something like this. That's what a normal cos graph would look like. So if you flip it, you expect it to look something like this now. Okay? Thank you. So that's what you should expect. That's roughly the shape, estimately, between 0 to 2 pi. But remember, there is a translation as well. So, before we do so, let's have a look. What's the 3 do again? What does this 3, which is a dilation factor, what does the 3 do to the graph?
It increases the gradient by 3.
Not the gradient?
The height by 3.
The height by 3 and the minimum by 3. So it's a vertical stretch. Okay, so it stretches the peak up. So I know that this now gets stretched up and this one gets stretched down. So you should expect the graph to look something more like this now, where we know that the minimum should be -3, maximum is 3. That's what you should get so far. Then they tell you with this 2 here, what does this 2 tell us? So I'm going to write here, this is the amplitude, because 3, so remember amplitude can never be negative. What about that 2? What does the 2 do?
You put like another bracket, so it's like less confusing.
Very good. That will affect your period. Very good. So the period is normally given by 2 pi on n. I normally don't like using the formula because I like you to understand what's actually happening. I like to describe it as period of 2 pi is your normal unit circle. And what you're doing now is you're doing a dilation. So it means a stretch. In this case, remember, it's always the stretch of the inverse. So if it's times by 2, then the inverse of that would be 1 on 2. Okay, so 1 on 2. That's what you're doing. So instead of stretching horizontally by a factor of 2, until you learn transformations, that chapter, then you understand this actually becomes the reverse. So you actually, if you put a 2 there, what it does is it halves. So it actually compresses the graph smaller rather than stretches it out wider. So the 2 pi, which is normally this length, is now being compressed by half. That's why the period now becomes pi. What's wrong with my pen? So annoying. Let's use another pen. But in the meantime, I'm going to have to restart again. Disable. And it does this funny thing where it disconnects. And then I enable. Cool. Reconnect. Change the screen. Back to duplicate. All right, we're back. Q. Okay, so where were we up to? Period. Period is now pi. So what does that mean? It just means the graph, where it used to be an inverted cos graph, where it's a length of 2 pi. So if I drew it again, it used to be like this, and that was 2 pi. It now becomes half that length. So it becomes pi, essentially. Okay, so that's what the 2 does. Now, keep in mind this also in I now, 14i has this theta plus pi on 2. So in every other chapters that I've taught you in the past, hopefully you remember this is a translation. This moves it left or right, and the technique I taught you was to let it equal to 0. And if you solve for that, you can see it says theta is minus pi on 2. So what does that mean? It just means left by pi on 2. Okay, so if we look at the graph, I'm explaining it so that you can see how I break it up into pieces and what I'm seeing when I look at the equation. Yeah. So in my mind, I see this graph shifting to the left by pi on 2 like that. That's what I'm seeing. Okay, so it shifts to the left by pi on 2. How accurate it is, doesn't matter. I just needed to know roughly what I need to solve. Okay, so this is how I do it. When I do this, and I've got videos on this example as well, but since I'm in class, I'm going to do this with you. This is how I do it. The first thing I do is I do a mock-up graph, just to begin with. So I do a nice mock-up, and I say, all right, so I know that it normally looks like this, and I moved it to the left. This is the starting point. We knew that it had to be -3 to 3. So starting point was at 0, -3. What I do is I say, well, if you move it to the left by pi on 2, then your new graph, your new starting point should now be at negative pi on 2, -3. Okay, so the first thing that I look for is this starting point. Okay, so that's the key thing. You want a starting point. So I call it SP. You probably won't find it anywhere else. I just call it SP. So I say starting point is at negative pi on 2. Okay, we had our period before. We knew that one cycle was equal to pi, but now I'm going to teach you what we call quarter cycles. Okay, so I'm going to call it QC for quarter cycles. The reason why we do quarter cycles because this graph is broken up into 4 key points. Okay, just like a unit circle, it goes from 0 to 90 degrees. So your cos graph from 0 to 90 degrees, cos of 90 gives you 0. So that's the first point. The second point, so that's your first angle. Then you reach to 180 degrees, which makes it a maximum length. That's why you reach here. So that's your first point, first quarter, second quarter. Then after the 180 degrees, you drop back down to 270 degrees, which that makes it 0. X value is 0. And then after 270, you go back to 360. That's why you're at your maximum length. So I do quarter cycles. Okay? Yeah.
Is it okay to call it the SP as the reference point?
Yeah, reference point, SP. I'm just using whatever at this point. Yeah. Okay, so you got a reference point or a starting point. So QC, quarter cycle, means you're going to divide that period into 4s. So the period is pi. I want you to divide that by 4. So what that means is, and I'm going to rub this out for now, you've got quarter cycles. So I'm just going to draw lines. Every quarter, your circle, your unit circle, you're moving from 0 to maximum to 0 to minimum to 0. That's what I want you to follow. So if you think about a cos graph normally, right, this is what a cos graph normally looks like. The quarter cycles work like this. The first quarter gets you to center. The next quarter gets you to minimum. The next quarter gets you to center. The next quarter gets you to maximum. The next quarter gets you to center. Next quarter gets you to minimum. So you start to see a pattern here that if you follow that pattern, you get this continuous cycle. That's why we want to find the quarter cycles. Yep.
So what's the difference between a cos graph and a sine graph?
So cos graph starts off, notice where it starts off right now. It starts off at the very maximum.
Sine graph is just the opposite of that, so it's flipped, basically.
Not necessarily flipped, it starts off at 0. So this is what a sine graph would look like, where it'll be like this, and then you finish
It's when,
like that.
we start at the start of the circle, x is 1 and y is 0.
That's one way to think about it. Sine graph is actually just talking about the y value. So you see, when at 0 degrees, the cos value, which is the x value, so cos, the x value is at a maximum of 1.
Yep.
True? Whilst at this point, if I asked you what is the sine of 0 degrees, 0. That's why the sine graph starts off at 0, yet cos starts off at 1. That's the only difference between the two. So as you move around the circle, the y values change and the x values change. The x becomes now, at this point, x is 0, but the y value is maximum. That's why you see in the sine graph, it's a maximum at the first cycle, whilst cos graph becomes a minimum or 0 at that point. So really this sketch is just more of describing what's happening as you're moving around the circle. Okay? So I want you to find, the first thing is to find the quarter cycle. So you got pi on 4. That means to go from one point, right now you're at the minimum. See, we know that's in the minimum. So the next quarter should bring you to the center. Okay? So we need to know how far it is from negative pi on 2 to get to your next quarter cycle. And this is where we start. So SP, we had negative pi on 2 as your point of reference. So on your x-axis, you had negative pi on 2. You know, to get to the next quarter cycle, we needed to add on extra pi on 4. Okay, so here we go. Let's work out what negative pi on 2, so that's your point of reference, so SP, plus your quarter cycle, pi on 4. Let's work that out. If you add these two together, we know that we need the denominators the same. That is true, but I want you to see the...
Negative pi on 4.
Good. So this now gives you negative 2 pi on 4 plus pi on 4. This is what I want you to see. The point is not the answer. See, I'm not interested in the answer. I'm interested in what I'm converting it to. So this is my starting point. Negative 2 pi on 4 is my starting point. I'm adding on, that's how many, and what the distance is to get to the next quarter cycle. So the beauty here is, now that I know, all I'm really doing is I'm adding extra 1. Every time I go to the next quarter, I'm only adding an extra quarter. See that? So if I write this down for you to see, instead of negative pi on 2 here, it was easier to write it as negative 2 pi on 4, because it means the same thing. To get to the next quarter, we knew that we're just adding one more quarter. So now this must be negative pi on 4. The next quarter has to then be 0, because you're adding another pi on 4. You see what I'm doing? I'm adding another pi on 4. The next quarter now is pi on 4. If I add another quarter, that now gives me 2 pi on 4. Now the beauty of doing this, okay, so when you're sketching it, see, when I ask you, if you were to sketch this graph, see, you knew at negative 2 pi on 4, your starting point was at the minimum. Then the next quarter cycle, you had to be at the center. The next quarter cycle, you had to be at the maximum. At the next quarter cycle, you had to be at the minimum. At the next quarter cycle, you now have to be at the minimum again. So what you can see here is I already just got the graph of a cos graph, just simply following that pattern. So if I wanted to sketch this all the way, it's really easy. See, I just follow that pattern. I say, all right, well, the next one is 3 pi on 4. Next one is 4 pi on 4. Next one is 5 pi on 4. Next one is 6 pi on 4. Next one is 7 pi on 4. Next one is 8 pi on 4. And that gives you your 0 to 2 pi. So we want it only from 0, so from this point to 2 pi, so 0 to 2 pi, I just need to follow this pattern. So if I follow the pattern, this goes to center, maximum, center, minimum, center, maximum. If I follow it, that's my graph. But what am I sketching? I'm only sketching from 0, which is from here, all the way up, all the way down, all the way back up, and that finishes at 0 to 2 pi. And you can see it was so much easier when I draw it now. This is my graph. There you go. I haven't done much. All I did was work out the quarter cycle, and I worked out my point of reference, and I already got a really nice graph. I know what the maximums and minimums are already. I knew it was meant to be -3 to 3. I've shifted the graph already because that's where my reference point was. And I just followed quarter cycle, quarter cycle, quarter cycle, quarter cycle, quarter cycle, and I followed that pattern. So right now, if I was asked to sketch from -pi to pi, I can still do it because you just simply follow the quarter cycle to put in the points. And that's all I did. So moving left and right is actually nice and easy because you didn't have to work out your x-intercepts. All of it moved nicely. I already got pi and 4, 3 pi and 4, 5 pi and 4, and all of that was found just simply following quarter cycles, because every quarter cycle I was already finding my x-intercept. That's why 14i is easier. 14j, when you move this graph up or down, you can't rely on these x-intercepts to be correct. That's why 14j is much more tough, or at least tougher, because you have to work it out. This one's much easier. All you have to figure out is starting point, quarter cycles, how far do you need? You just need to convert this part. That was the most important part here, to convert it so that you can find each quarter cycle so your scale is correct. See, because I changed that to -2 pi and 4, the scale worked out nicely. That's why I was doing that. Okay, so that's the key step that I want you to look at. Have a look at this video, have a look at my other videos as well. It's the same thing. I'm trying to change it to the quarter cycles, and you follow the pattern. It's minimum, maximum, minimum, maximum, or sorry, minimum, center, maximum, center, minimum, center, maximum, center, minimum. It follows the same pattern. The difference between a cosine and a sine graph is where you start. Do you start at the minimum? Do you start at the center? Or do you start at the maximum? Once you find that point of reference, or the starting point, you follow the quarter cycles, and it should, one, your sketches will be nicer. So my sketches are very simple. I did it very neatly. If you don't do that, usually the graphs look terrible. It's very skewed or skinny, but by doing it, see, I've kept it nice in scale, and all I did was just follow this quarter cycle. I didn't do a lot of thinking. I haven't done any solving. I haven't done anything else but quarter cycles and starting point. Okay, so that's 14i. So as you're going through 14i, and I just did the hardest one, by the way. So that means you can do all the other ones without the negatives. It'll be much easier. If you're going through these ones, they're even easier because they don't have a dilation, and they don't have a dilation here. So they're just moving left and right. So you should find that moving these ones are much easier. It's when you get to J, that's where learning the quarter cycles will really help to sketch. So most of you will be able to sketch it. It's the solving part that will be difficult. Okay, so try to follow the quarter cycles, watch my videos and really learn the quarter cycles. If you want more explanations of how to start it, let me know. I'll make more videos on how I do a quarter cycle and sketch them. Okay, but quarter cycles is what I think helps students to sketch neatly, and it gets you sort of a pattern that you can work with. Okay, so I'm going to stop.